In our final example in this section, we're not even going to solve it. It's a word problem that all we want to do is set it up. So let's read what it says. Bubba plans to study all day for his upcoming final exams. He plans to eat all of his meals at a nearby deli. He will eat only two things: steak sandwiches and potato soup. And here's the nutrition chart for both of those foods. Steak sandwich, 400 calories, 12 grams of fat, 9 grams of dietary fiber. Potato soup, we'll assume it's a cup of soup each one, 200 calories, 8 grams of fat, and 5 grams of dietary fiber. Bubba wants to restrict his daily diet to no more than 2,000 calories and no more than 64 grams of fat. How many servings of each food should he choose to maximize his dietary fiber? Set up the problem. We will find the objective function and the constraints, the inequalities, but we will not solve. So this is a maximization problem. We want to maximize his dietary fiber. Well, the first thing we need to do is define our variables. What do you think the variables are going to be? We'll call them x and y, where x will be the number of steak sandwiches and y will be the number of cups of potato soup. So let's define x to be the number of steak sandwiches and y will be the number of, I'm just going to write number of potato soup, which means whatever it is. I think I said we'll define them to be cups of potato soup. Doesn't matter if they're cups or bowls or whatever. All right, now we need to figure out what x and y are. So let's first set up the maximization equation. What is it we're trying to maximize? It's his dietary fiber. Well, how much dietary fiber is he going to get? He's going to get 9 grams of it with every steak sandwich and 5 grams of it with every cup of potato soup. So let's make the equation. We are going to maximize the function, and maybe I will call it F for fiber. Fiber is equal to 9 times x plus 5 times y. Now make sure we understand that. This is our objective function that we want to maximize. That's because if x is the number of the number of steak sandwiches, 9x is the number of dietary fiber grams he's going to get from those steak sandwiches because of this number right here. And potato soup has 5 grams of dietary fiber per cup of potato soup. So it would be plus 5 grams times the number of cups of potato soup. So that's the function we need to maximize. And now we need to come up with inequalities that will be our constraints. So we need to use all the information that was given to us. Let's look at this first line. Bubba wants to restrict his daily diet to no more than 2,000 calories. No more than, we can't go over that. So we're going to have some inequality that looks like this. At least on the right-hand side, something is going to be less than or equal, which means at most 2,000 calories. How do we determine the number of calories based upon x and y that he's going to intake? Well, let's see. Here's the calories. Each steak sandwich is 400 calories. The potato soup is 200 calories per cup. So 400x plus 200y would give us the total number of calories that he's going to take in. 400 times the number of burgers plus 200 times the number of cups of potato soup. That has to be less than or equal to 2,000. Based on this line right here, he wants to restrict to no more than 2,000 calories and no more than 64 grams of fat. no more than that. So something has to be less than or equal to 64. And what has to be less than or equal to 64? His intake of fat. So come back up to this table. Here's the fat. The steak sandwiches are 12 grams of fat each. The potato soup is 8 grams of fat per cup. So 12 times x plus 8 times y, 12x plus 8y, has to be less than or equal to 64. And now we've used all of the information. There is one minor thing that we should always remember. You cannot eat a negative number of steak sandwiches or a negative number of cups of potato soup, so we'll include the two inequalities that we frequently do with these real-world problems. X has to be greater than or equal to 0. Y has to be greater than or equal to 0. So this collection of inequalities would be our constraints or inequalities, and we're maximizing this function based upon these inequalities. And again, we don't need to solve this problem, we just needed to set it up.